In this example, we're going to sketch a graph of the function 1/2 times tangent of the quantity 2x minus pi over 2 plus 1 for at least one period. For this situation, I'm going to apply the t-table method using the adjusted set of values based on the fact that I'm working with tangent. I'm not going to use the typical values that I had done before for sine and cosine, that being 0, pi halves, pi, 3 pi halves, and 2 pi. The reason for that is because all I would get are asymptotes and values along the midline. In this case, I'm going to use the values for tangent that span from negative pi halves up to pi halves with increments of pi fourths in between. So that means the original set of values I'm going to work with for x and tangent of x, I'm going to work with negative pi halves, negative pi fourths, 0, pi fourths, and pi halves. If I was instead working with cotangent, it would instead be recommended to use the values from 0 to pi with pi fourth values in between. So this is the set of values I will use where we have asymptotes at the edges, 0 in the middle, and in this case 1 and negative 1 at pi fourths and negative pi fourths respectively. If it gets confusing as to which one is 1 and which one is negative 1, keep in mind what quadrant those would lie within the unit circle. Pi fourths in the unit circle would be in quadrant 1, where everything is positive, whereas negative pi fourths would be in quadrant 4, where tangent is negative. Before moving on, however, just like with the previous functions of sine and cosine, I'm going to take the original function and I'm going to factor out the value that is multiplying x. Meaning I'm going to rewrite this function instead as 1/2 tangent of 2 factored out of that expression, which would leave me with x minus pi over 4 plus 1. Just like with sine and cosine, this will isolate the effects of the period change and the phase shift. However, unlike with sine and cosine, keep in mind that tangent has a period of just pi, which is going to change what we would expect to see with this. In terms of the t-table method, though, just about everything is still the same. With tangent of x, the first thing I'm going to do to the y-coordinate values is I'm going to use the amplitude. The amplitude is what is operating on tangent in front of it, either a multiplication or a division. In this case, we have that we are multiplying by 1/2. You could also think about that as dividing by 2. And that's what I'm going to do to each of my values. I am going to multiply by 1/2, or divide by 2. That will leave me with still asymptotes. The y-coordinates for the other values are going to be negative 1/2, 0, and 1/2. Then we have the vertical shift, which is the plus 1 that we have. And because we have plus 1, we're just going to add 1 to each of my values here. My asymptotes still stay where they are because this is just the vertical amount for the asymptote, which, since it's a vertical asymptote, does not change. But the other values will now become 1/2, 1, and 3/2, or 1.5. All right. Then we have our x-coordinates. Just like with sine and cosine, the first thing I'm going to apply is the period change. This is not what the new period is. The new period of this function, if you are curious, if you take the original period of tangent and divide that by the amount that we had factored out, that gives you the period. Meaning it should only take pi halves for it to repeat itself now. However, what we did to the period is what we're also going to do to all my values. This number that we factored out, that is a multiplication of 2, we are actually going to divide by that, giving me now negative pi fourths, negative pi eighths, 0, pi eighths, and pi fourths. Note that the distance from my lowest value to the highest value in this range, negative pi fourths to pi fourths, is a distance of pi halves, which is the new period. Lastly, we have our phase shift. Our phase shift is the value on the inside of the brackets here. Because we have minus pi fourths, that means we are going to be moving to the right by pi fourths. So we are going to add pi fourths. This will give me 0, pi eighths, pi fourths. Pi eighths plus pi fourths is 3 pi eighths. And pi fourths plus pi fourths is pi halves. I now should be able to make my graph. I have my x coordinates over here, and I can link those with new y coordinates. I will start with the asymptotes. I have at 0 is one vertical asymptote, and at pi halves is my other vertical asymptote for one period. So I have one vertical asymptote here, and another vertical asymptote here. I also have at pi eighths a value of 1/2. So that will put me about here. I have at pi fourths a value of 1. Puts me about here. And at 3 pi eighths, a value of 3/2, or 1.5, which puts me about here. Now to connect this graph, I'm not just going to connect this as a straight line, even though it kind of looks like that. Keep in mind that we have asymptotes, which means as the function approaches that asymptote, it gets closer to it, but it cannot cross it. And what this means is as I'm increasing from my new baseline or midline here, which is now at +1, I am increasing up to this point and then towards the asymptote, but I will never touch it. And likewise from that midline, I will decrease towards the asymptote, but never touch it. This would be one period of this function. However, you can see another period of this function that will appear from negative pi halves to negative pi fourths and would look something like this. The question, however, only asks us for one period of the function, so we don't need that second part if you would not want to have that. But that is what the rest of the graph would look like, or at least one more period of it.